In last lecture, we are discussed about microprocessor and organization of 8085. Microprocessor is simply programmable register multipurpose device that accepts digital data as input and process it according to instructions stored in its memory and provide results as output. It is also capable of performing various computing functions and making decisions. Mainly, microprocessor has three blocks: arithmetic logical unit, registers, and control unit. In arithmetic logical unit, all the arithmetical and logical functions are proceed. In registers, it is a storage and control unit. It sends the control signals to control all microprocessor systems. After that, we discuss about evolution of microprocessor. Discuss about block diagram of microcomputer system. In block diagram of microcomputer system, there are 5 blocks. That is keyboard. It's an input device which is used to enter data. MPU, microprocessor unit, ROM, read-only memory, RAM, display interface, and display. Now next point is block diagram of generic microprocessor. Block diagram of generic microprocessor consists of mainly 7 blocks. First block is arithmetic logical unit. It contains several registers that are instruction register, accumulator, stack pointer, status register, temporary register, and data address register. Next block is a program counter, instruction decoder, timing and control section, bus, buffer and latches, and last interrupt control. Registers are marked with red color. Now next, first block is ALU, that is arithmetic logical unit. This unit performs arithmetic and logic operations, and this unit also performs rotate operation. The operation in this unit affects the status register. The result from arithmetic logical unit are placed in accumulator. Register. Now we discuss about registers. First register is accumulator. Accumulator is an 8-bit register used to store 8-bit data. In arithmetic and logic operation, result is stored in accumulator. Next is instruction register. This is also a 8-bit register. The first byte of an instruction is stored in this register. Means instruction that is executed next, which is stored in instruction register. Next is program counter. It is a 16-bit register containing the address of next executable instruction. Accumulator, instruction register are both 8-bit registers, and program counter is 16-bit registers which stores the address of next executable instruction. It can be incremented or reset by the control section. Next is status register. Status register is called as flags, which consist of flip-flops that are set or reset according to data conditions in accumulator. The generic microprocessor has two flags, that are zero flag and carry flag. Next is a stack pointer. It is a 16-bit register consisting of address of memory location called stack. Stack is read or write memory used for temporary storage. Next is data or address register. The data or address register is a two 8-bit registers that can be used separately or as a combined pair. They are labeled as H and L. H means higher bit and L means lower bit. They both separately 8-bit registers, means data register 8-bit, address register 8-bit, but they can be used combined. When used in pair, they can address 16-bit. Next is instruction decoder. Instruction decoder interprets the content of instruction register and determines exact steps to be followed in executing the entire instruction. It directs the control section accordingly. Next is timing and control unit. This section receives the signal from the instruction decoder to determine the nature of instruction to be executed. And also it sends the timing and control signals to all parts of microprocessor. Next is address bus. Address bus is of 16-bit. The address bus is a group of 16 lines generally identified as A0 to A15. Address bus is unidirectional bus, that is, bits flow in only one direction from microprocessor unit to peripheral devices. Next is a data bus. Data bus are of 8-bit. They are group of 8 bits used to data flow. Data bus are bidirectional bus, that is, data flows in both direction between microprocessor unit and memory and peripheral devices. Next is bus, buffer and latches. Latch is a flip-flop used to store one bit of information, and information is stored into latch by enabling buffer. So this is the explanation of generic microprocessor. Next topic is pin diagram of microprocessor 8085. 8085 chip is available in 40-pin plastic ceramic package. That is, 8085 pin diagram consists of 40 pins. This is pin diagram of microprocessor 8085. Pin VCC, it's a positive power supply. It is common collector voltage. Next pin is hold. It indicates that a peripheral such as DMA, that is direct memory access controller, is requesting the use of address and databases. Means it's a request for address and databases. When microprocessor receives a hold request, that it release the use of the buses as soon as the current machine cycle is completed. Internal processing may be continued. After the removal of hold signal, microprocessor get back the bus. Next pin is HLDA, that is hold acknowledgement. It is a signal for hold acknowledgement. HLDA output indicates to a peripheral that a hold request has been received and that the microprocessor will relinquish control of buses in the next clock cycle. After the removal of hold request, HLDA goes low. Next pin is clock out. The whole circuitry is synchronized with the clock. And also the speed of system depends on clock frequency set. Next pin is reset in. When the signal on this pin goes low, the program counter is set to 000H, means program counter set to 0. The buses are tri-stated. Now, what is tri-state? Tri-state means 3 state, that is logic 0, logic 1, and third state is high impedance. Impedance means electrical resistance. In high impedance state, the pin neither connected to supply or nor connected to ground. Hence, impedance at this pin is very high with respect to supply as well as ground. In microprocessors, some pins are 3 states. In high impedance state, the pin is disconnected from the internal circuit of microprocessor. But it disconnected electronically but not physically. In this state, the processor is disconnected from the bus. So in reset in, the buses are tri-stated and microprocessor unit is held in reset condition as long as a reset is applied. It also reset interrupt enable and HLDA flip-flop. Next pin is ready. It is the input signal used by the microprocessor to sense whether a peripheral device is ready to transfer data or not. In some conditions, some peripheral devices are slow. At that time, this pin is used. This sends the signal to delay microprocessor until a slow responding peripheral is ready to send or accept data. If ready is high, the peripheral is ready. If it is low, the microprocessor waits for an integral number of clock cycles until it goes high. It is used to synchronize slower peripheral to faster microprocessor. Next pin is I0 or memory. It's the input output or memory. This pin indicates it is a status signal that indicates whether the address bus is for input output device or for memory. When this pin goes high, the address on the address bus referring input output device, and when it goes low, the address on the address bus referring memory. It is tri-stated during hold and halt. Next pins are S0 and S1. S1 and S0. These are status signals sent by microprocessor to distinguish the various operations or type of machine cycle in progress. Status code for Intel 8085, S1 and S0. When both are 0, operation is halt state. When S1 is 0 and S0 is 1, it's a write state. When S1 is 1 and S0 is 0, its operation is read operation. When both are 1, it's a fetch operation. Next pin is read. RW, that is read. This is a read signal, read control signal. This is active low signal. This signal indicates that selected input output or memory device is to be read and data is available on data bus. It is also tri-stated during hold and halt state. Next pin is WR, that is a write. It is a write control signal. This is also active low signal. This signal indicates that the data on data bus are to be written into selected memory or IO locations. It also tri-stated during hold and halt state. Next is ALE, that is address latch enable. One special output signal generated by microprocessor to indicate beginning of the operation. Means ALE indicates only the beginning of the program or the beginning of the operation. It is positive going pulse generated during first clock cycle of machine state, and it indicates that the bits on AD7 to AD0 are address bits. The signals enables the lower 8 bit of the address from the multiplex bus to latch into external flip-flop or peripheral devices. ALE is never tri-stated. Next is address bus. In microprocessor 8085, there are 16 address lines. From A8 to A15 are separate address lines, and A0 to A7 are multiplexed with D0 to D7. Now, from A8 to A15, the most significant bits of address bus are separate, that are A8 to A15, the least significant bits A0 to A7 are time multiplexed with the bits of bidirectional data bus from D0 to D7. The 8 signal lines A8 to A15 are unidirectional and used as high order address bus. And from AD0 to AD7 are bidirectional. They serve as dual purpose. They also used as low order address bus as well as used as data bus from D0 to D7. During execution and instruction, in execution, during the earlier part of the cycle, these lines are used as low order address bus, and during latter part of the cycle, these lines are used as data bus. However, the low order address bus can be separated from these signals by using a latch. And from AD0 to AD7 are bidirectional and they are low order address bus, and A8 to A15 are high order data bus. Now, next pin is INTA. INTA is an abbreviation for interrupt acknowledgement. A low INTA indicates that the processor has acknowledged an INTR interrupt. And next pin is INTR. INTR is a level 3 maskable interrupt request input signal. That is, it's a maskable interrupt request signal. This is a general purpose interrupt with lowest priority. When the interrupt signal is given on this line, the microprocessor executes interrupt acknowledge cycle to read interrupt information from interrupting device. When this arrives, program counter does not increment its contents. The INTR is enabled or disabled by a software. Next, three pins are restart interrupt, and RST 7.5 is a restart interrupt. This signal is used to interrupt the microprocessor. When an interrupt is recognized, the next instruction is executed from a fixed location in the memory, that is 003CH. It is a maskable interrupt. They cause an internal restart to be automatically inserted. Next pin is trap. This signal is used to interrupt the microprocessor. It has highest priority among interrupts. When an interrupt is recognized, the next instruction is executed from a fixed location in the memory, that is 0024H. It is a non-maskable interrupt. It is unaffected by an interrupt enable or mask. Means pin RST 7.5 is used to interrupt the microprocessor, and trap is also used to interrupt the microprocessor. But 7.5 is for maskable interrupt, and trap pin is for non-maskable interrupt. Next pin is SOD, that is serial output data. It is a data line for serial output. The 7th bit of the accumulator is outputted on SOD line when instruction is executed. The SOD line eliminates the need for an output port in the software control serial input output. Next pin is reset out. This pin indicates that the microprocessor unit is being reset, and it is connected to peripherals to reset them when microprocessor unit is reset. Means it only resets the devices connected to microprocessor when the microprocessor is reset. Next, X1 and X2. X1 and X2 both are connected to external crystal or an RC or LC network, which drives an internal circuitry of the microprocessor. It produces a suitable dock for the operation of microprocessor. The frequency is internally divided by 2. Therefore, the crystal should operate twice the operating frequency. The operating frequency range of 8085 is 500 kHz, is 500 kilohertz to 3 megahertz. Okay. Pin diagram of microprocessor 8085 is completed.